I have to be completely honest with you right out of the gate here.
Oh, boy. Okay. Lay it on me.
I have been staring at my screen for, I don't know, the last 3 days straight,
Mm.
just looking at Phase I Business Understanding from this CPMAI study guide.
Right.
And I feel like I'm hitting a wall, like a very, very thick bureaucratic brick wall.
Yeah, that is actually a really common feeling.
Is it? Because I feel like I'm losing my mind.
You're not, I promise.
Yeah.
Phase I it's deceptively simple. I mean, it looks like just a list of meetings on paper, but it's actually the foundation of the entire methodology.
Well, it's incredibly frustrating. I've been prepping for this exam, right?
Yeah.
And I am looking at the material you sent over. And I see all these terms like trustworthy AI, go, no go, performance values.
The big ones.
Right. And in my head, I'm thinking, okay, I get it. Define the problem, set some goals, move on.
Sure.
But then I try to actually do the practice scenarios on it.
And it falls apart.
Exactly.
Exactly.
I keep getting them wrong. Specifically, I keep mixing up the safety checks.
Okay, let's drill into that. Which ones specifically are tripping you up?
The really big one is trustworthy AI requirements versus the AI go, no go gate.
Ah,
They feel like the exact same thing to me.
they do, don't they?
Yeah, they both feel like a safety check where you sit around and ask, hey, is this project okay to proceed? But apparently, in the eyes of the CPM AI framework, they're completely different animals.
Completely different.
I treat them as synonyms. And the practice test treats that as a massive failure.
I will tell you right now, mixing those two up is probably the single most common way candidates fail the Phase I section of the exam. You are definitely not alone there.
Okay, that makes me feel slightly better, but also way more terrified because the real exam is coming up fast.
We'll get you there.
So here is my request for this deep dive. Can we slow it right down?
Absolutely.
Because I want to stop guessing. I want to actually understand the difference so I can stop staring at this study guide in total despair. I don't want the textbook definition anymore. I want the actual logic behind it.
We can absolutely do that. And frankly, slowing down is the only way to get this right.
Yeah.
We need to unpack the why behind these terms, not just the what. So let's frame this before we dive into the specific vocabulary.
Okay.
If you had to describe Phase I in a single sentence, and based on what you read, be honest about your impression, what would it be?
I guess I'd say it's the planning phase. Like, it's where we write the project charter.
Okay, that's a bit too broad.
Right.
And it kind of misses the teeth of the phase.
The teeth.
Yeah, the enforcement part. Let's sharpen your definition. Phase I is where we define the problem and the rules before we touch a single line of code.
Before we touch code.
Exactly.
That seems to be the universal mantra here.
It is. CPMAI is rigorous about this. You don't just start hacking away at a data set to see what happens.
Right.
You define the boundaries first. Now, within Phase I, you have specific task groups. We have things like determined business objectives.
Which I saw was marked as high priority.
It is high priority. But for the exam, and honestly, for real-world failure proofing, the critical priority items are the ones you just mentioned.
Trustworthy AI requirements
Yeah.
and the AI gonna go.
Exactly. Those are the critical priority tiers.
So those are the heavy hitters.
They are. Think about it this way. If you mess up the business objectives, you might build a useless model.
Waste of time, basically.
Right. But if you mess up trustworthy AI, or the go-no-go, you might build a dangerous one, or one that gets the company sued.
Oh, yeah, that's definitely worse.
Much worse. So here is how we are going to run this deep dive today.
I'm ready.
I am not just going to read bullet points to you.
Thank goodness.
I'm going to give you scenarios, actual exam-style situations. And for anyone listening to us right now, I want you to do this too. You have to mentally pick an answer before I reveal the correct one.
No passive listening today.
No passive listening. You have to commit to an answer out loud, and the listener has to commit in their head.
Okay. High stakes?
Yeah.
I like it. Let's do it.
All right, let's jump right into segment 1, our top terms. We're going to tackle that confusion you have right off the bat.
Bring it on.
Term number 1, trustworthy AI requirements.
Literally the bane of my existence this week.
Let's demystify it right now. Phase I isn't just about asking, how do we make money with this model?
Right.
It requires documenting ethical guardrails, legal obligations, explainability, and failure modes before any modeling begins.
See, okay, pause right there.
Yeah.
That is the exact part that trips me up.
The before modeling begins part.
Yes. How can I explain how a model works or how it might fail if I haven't even built it yet.
Ah.
It feels like I'm writing a review for a movie that hasn't even been filmed.
That is the ultimate intuition trap, and it catches a lot of smart software developers. Let me give you a metaphor.
Okay, I need one.
Think of trustworthy AI requirements like a building's fire code review.
Okay, fire code. I am picturing blueprints and lots of municipal red tape.
Exactly.
Yeah.
So, do you conduct the fire code review after the tenants have moved in and you've already built the skyscraper?
Well, no, obviously not.
Why not?
Because if you do it after it's built and you fail, you might have to tear down literal walls to put in sprinkler systems.
Yeah.
You'd have to rip out the wiring. It'd be a disaster.
Precisely. Retrofitting is expensive. Designing it in from the start is cheap.
Okay, I see where you're going with this.
If you wait until the AI model is already built to ask, hey, is this actually legal? Or is this ethical? Or can we explain how this works to a regulator?
You've essentially built a building without a fire exit.
Boom. Exactly. You might have to scrap the entire $1 million project.
Okay, that actually clicks. So it's the blueprint stage.
Yeah.
You're defining the constraints of the architecture before the architects start drawing.
You're setting the rules. Let's test that click with a scenario. I want to introduce a hypothetical project we can follow for the rest of our time today.
Right.
Let's call it Metasort.
Metasort. Catchy. What do they do?
Imagine a massive healthcare provider wants to build an AI system to automatically triage patients in the emergency room based on historical data.
Oh.
Yeah, they want the AI to predict who needs a bed immediately and who can wait in the lobby.
High stakes. Life or death, potentially.
Exactly, the highest stakes. So they're launching a Phase I effort for this AI triage model. The project manager, let's call him Steve.
We all know is Steve.
Steve is very focused on speed. He wants to get to the coding. So Steve wants to defer the specific compliance documentation and the required AI explainability tasks until Phase 6.
Phase 6 is deployment, right?
Correct. The very end. His argument is actually quite logical, though.
Let's hear Steve's logic.
Steve says, look, we don't know which algorithm we're going to use yet. Maybe a neural net, maybe a random forest. We can't document how to explain it until we select the actual algorithm.
That does sound logical.
He adds, regulatory review happens at the end of the project anyway, so let's just wait until we have a working model to show them.
Okay.
You are the CPMAI expert brought in to audit. What do you say to Steve?
My gut reaction, like the one I would have had 10 minutes ago, would be to agree with him completely.
Because it sounds efficient.
Yeah. It sounds super efficient. Why document explainability for a model that might not even work? It feels like wasted paperwork.
But
based on the fire code metaphor,
lock in your answer. Does Steve get to wait until Phase Bill?
I am going to say he is wrong. You have to do it now in Phase I.
You are correct. But why are you correct? Why can't we just wait and see what the data science team builds?
Because if we build a black box model that can't be explained like that neural net Steve mentioned,
Yep.
and then we find out later that the hospital regulations or the actual laws require explainability,
Then what
we
happens?
basically have to throw the whole model in the trash because we can't legally use it.
Precisely. Under the CPMAI framework, required AI explainability considerations and required compliance with regulations and laws are strict Phase I tasks.
Because you are defining the constraints.
Yes. If the law says you must be able to explain exactly why a patient was denied an ER bed, that is a hard constraint on your model design.
Right. It forces the data scientist to choose an algorithm that supports that level of transparency.
Exactly. You literally cannot use a deep neural network that gives you zero visibility if the law forbids it. If you defer that requirement, you risk building something illegal by design.
You have to tell the builders, we need fire exits before they pour the concrete.
So what is the memory hook here?
Trustworthy AI is the blueprint fire code, not the final building inspection.
Bingo. Fire code, not final inspection.
Caught it. Okay, I am writing that down.
Now let's move to the second term, the one you keep confusing it with.
AI go, no go.
AI go, no go.
Okay, hit me. This is the one where my brain just gets muddy.
The AI go, no go is a very specific gate. It is a decision point. Before committing resources to the next phase, the team must answer 3 very specific questions.
Okay.
Number 1, is the business problem solvable? Number 2, is the data there? Number 3, can we execute?
So that's business, data, and execution.
Correct. Those are
Yeah.
the 3 feasibilities you're testing.
Okay.
Here's the metaphor for this one. Think of the go, no go like a bank's loan approval process.
Okay, sticking with finance, I can track that.
To get a mortgage from a bank, you usually need 3 things to line up: good credit, good collateral, and good income.
Right. You need the whole package.
Exactly. If you walk in and you have a massive income, let's call that business feasibility, meaning your project will make a ton of money,
Okay.
but you have absolutely zero collateral, let's call that data feasibility.
So no data.
Do you get the loan?
No. The bank literally laughs you out of the room. They don't care how rich your business case claims to be if you have no assets to back it up.
Exactly. A great income doesn't fix missing collateral. And in AI, a great business idea doesn't fix missing data.
That makes total sense. You can't just wish the data into existence because the business case is brilliant.
But people try.
I think that's where a lot of tech startups fail.
Right.
Right? They pitch the grand vision. The business feasibility is huge, but they totally gloss over the fact that they don't actually own the data to train the model.
Happens every day. Let's apply this to our Metasort project.
Okay, back to the ER triage bot.
The business feasibility for Metasort is off the charts. It could save the hospital millions of dollars and actually save lives by drastically reducing wait times.
The ultimate win-win.
And the execution feasibility is green, too. They have a team of world-class data scientists sitting on the bench ready to code.
Sounds like a sure thing.
But the data governance team does their review for Phase I.
Oh.
They come back to the steering committee and say, hey guys, the patient records for the last 10 years are stored in scanned PDF images, not a structured database.
Oh man, scanned PDFs. The enemy of AI.
It gets worse, and half of them are handwritten by rushed emergency room doctors.
So completely illegible.
Pretty much. The data team says we don't have the technology to reliably read this handwriting with our current budget or timeline.
Wow.
So business is green, execution is green, data is red.
Ugh.
Can they proceed past Phase I?
Well, this feels exactly like the collateral problem from your metaphor. The collateral here is the data, and it's essentially worthless in its current PDF form.
Lock it in. Does Metasort get the green light to move to Phase II?
No, it absolutely stops here. It is a no-go.
Correct. And let me tell you, this is exactly where people failed the exam.
Really? Why? It seems obvious when you lay it out like that.
Because on the exam, they dress it up. They look at a scenario that highlights extremely high business value and a world-class IT team.
Right.
And the test taker thinks, well, 2 out of 3 isn't bad. The business value is too high to ignore. We can just fix the data later. Let's hire some interns to manually type it up during Phase II.
They try to negotiate with the framework.
Yes. But the go-no-go requires all 3 feasibilities to be independently green.
Business, data, execution. All 3.
All 3 must independently clear. The why here is crucial. If you don't have the data, the collateral, the project is basically dead on arrival. If you proceed anyway, you are just burning the sponsor's money.
So the trap for the student is thinking a genuinely great business case somehow outweighs fundamentally bad data.
Exactly. Now, to tie it back to your earlier confusion, I want you to notice something very important about what we just did.
Okay.
Notice what we didn't check in the go-no-go gate.
What didn't we check?
We checked if we could physically build it, right?
Yeah.
Did we ask if we should build it?
No.
Did we ask if the historical triage data might be biased against certain demographics?
No, we didn't even look at that. We just asked if we could read the handwriting.
Exactly. We just asked if we had the raw data to run the math.
Oh, okay. That is actually starting to separate in my brain now.
Tell me.
Go, no go is literally just, can we physically pull this off? Trustworthy AI is, should we pull this off? And are we allowed to?
Yes. You are getting ahead of me, but yes, that is the perfect exact distinction. We are going to drill that even deeper in segment 2.
I can't wait.
But first, I want to hit one more term that trips people up in this section.
Lay it on me.
Acceptable model performance values. And its twin, acceptable KPI performance values.
Okay, see, this one seems really straightforward to me. It's just setting goals,
Yeah.
right? Like saying, we want this model to have 90% accuracy.
It is setting goals, but it's the timing and the rigidity of those goals that catches candidates off guard.
Okay, what do you mean?
You must agree on exactly how good the model needs to be, meaning statistical accuracy, precision, recall,
Right.
and what business results it must drive. Those are the KPIs you have to do all of that in Phase I.
Before you build it.
Before you build it, here's the metaphor. Think of it like the passing score on a professional licensing exam.
Like the CPMAI exam I am currently suffering through.
Exactly like that. The certification board sets the passing score before you ever sit for the test. Let's say it's 80%.
Okay.
They don't wait to look at the class results, see that everyone did really poorly and averaged a 70, and then say, you know what? This test was hard. Let's lower the passing grade to 69 so more people get the certificate.
I mean, that would be fantastic for me personally, but yeah, that completely defeats the purpose of having a standard. It invalidates the whole license.
Right. It becomes meaningless. Now, let's take that back to Metasort.
Okay. ER triage.
In Phase I, the doctors and the hospital stakeholders sat down and agreed. For this AI triage system to be safe enough to use on real humans, it must have a 95% accuracy rate in predicting life-threatening conditions.
95%. That's the firm line in the sand.
They document it, they build the model, time passes. We are now in Phase V, the evaluation phase.
The moment of truth?
The model evaluates out at 92% accuracy.
Ooh, 92.
92%.
I mean, that's pretty close. And honestly, 92% might be way better than the human error rate in a chaotic emergency room.
It might be. But the Phase I document, the literal rule book they wrote at the start, required 95.
Right.
So the lead data scientist looks at this 92% and says, look, the real world data was way messier than we anticipated. 92% is actually really impressive given the complexity of the PDFs. Let's just update the Phase I document to say 91% is acceptable so we can mark this project as a win and launch it.
Oh, man. I see the temptation there.
It's strong, isn't it?
It is. Because in the real world, especially if you come from an agile software background, you'd probably just say, yeah, let's adapt. 92 is great for version 1. We'll iterate.
Be very careful here. You are currently wearing your agile developer hat.
I am.
I need you to take that off and put on your CPM AI auditor hat.
Okay. Auditor hat is firmly on.
The agreed rule was 95. We hit 92. Does the data scientist get to just lower the bar?
My instinct still wants to say that sounds reasonable in the real world, but since you used the licensing exam metaphor,
Lean on the metaphor.
I am going to say fail. They cannot do that.
You are correct. That is a hard fail.
But why is it so strict? Is it just bureaucratic rigidity?
Oh.
Because it feels a little inflexible for a technology that is inherently unpredictable.
It's not just bureaucracy. It is governance.
Yeah.
These are pre-committed values.
Pre-committed.
Yes. If you can simply lower the bar after the fact to make the arrow magically hit the bullseye, you aren't measuring success anymore.
You're just faking it.
You're faking it to protect your ego or your bonus. If 92% is genuinely acceptable to the doctors now that they see it, you have to go through a formal change control process.
Oh, I see.
You have to formally admit we missed the original target and then get the stakeholders, the doctors, the hospital board to formally agree to a brand new target based on the new reality.
Got it.
You cannot just slide the scale quietly in the background to get a green light.
Because that would be like the board secretly lowering the exam score so the school looks better.
Exactly. So what's your memory hook?
The licensing exam score. You absolutely do not get to change the passing grade after you see your own test results.
Precise.
Okay, wow. So those are the top terms.
Let's review them quickly. Trustworthy AI is.
The fire code. It's the blueprint constraint.
Go no-go with.
The bank loan approval. All three feasibilities have to be green.
And performance values are.
The licensing exam score, pre-committed and unchangeable without a formal process.
Fantastic. You have the vocabulary down cold.
I actually feel pretty good about those now.
Good, because now we need to level up. We are moving into segment 2, top concepts.
Right.
This is where we see if you can handle the logic puzzles. It's one thing to know the terms. It's another to apply them when the exam tries to trick you.
I am ready. What is the first concept?
Concept 1, pre-commitment to success criteria. We just touched on this with the 95% accuracy rule, but we need to go a layer deeper into the why.
This is the whole idea of locking things in early, right?
Yes. But I want to address a confusion you hinted at just a minute ago. You asked, isn't Agile about adapting?
Yeah. I mean, it still feels a little weird to be so rigid in Phase I's when we all know AI projects change so much.
Yeah, they do change.
Right. We learn things about the data in Phase 3 that we literally couldn't have known in Phase 1. So why pretend we know the perfect target accuracy on day 1?
Because adaptation is fine. Moving goalposts to fake success is not. This concept maps to 2 specific task groups in the study guide. Determine business objectives and AI system performance.
Okay, I remember seeing those.
Here's a harder scenario to illustrate this. An insurance company is sitting in Phase 1.
The insurance, got it.
The project manager documents the high-level business objectives. He writes down things like, we want to reduce fraudulent claims.
Makes sense.
But he deliberately defers setting any specific accuracy targets for the AI model. He tells the steering committee, listen, it is way too early to know what this neural network can actually do. We don't want to set a hard number that we can't hit and look bad.
Yeah.
Let's wait until phase 3 or phase 4, once we've played with the data a bit, to set the specific performance numbers.
Honestly, that sounds incredibly prudent to me.
Does
Yeah. Why set yourself up for failure? If you don't know the data quality yet, how can you promise a 95% accuracy rate? It's like promising you'll run a marathon in 2 hours before you've even bought running shoes.
It sounds prudent. It really does. But under the rules of CPM AI, is it correct?
I feel like you're leading me into a trap.
I am. Walk through it. If they don't set it now, what happens?
If they don't set it now,
Yeah.
then they haven't really finished phase I.
Keep going. Follow that logic all the way to the end of the project lifecycle.
Okay. If they don't set the target number now, then when they finally get to phase V to evaluate the model, they can just look at whatever the model happened to achieve, say it's only 60% accurate.
And what will they do?
They'll just draw a circle around it and say, success. Our goal was 60% all along. We built a great model.
Exactly. The Texas sharpshooter fallacy.
So I am going to say this PM's approach introduces massive governance risk. It's totally wrong.
You nailed it. It is entirely wrong. If you don't lock in the criteria in phase I, the entire phase V evaluation phase becomes mathematically meaningless.
It's like saying, I'm going to run a race, but refusing to decide where the finish line is until you get tired and stop running.
Oh, look, I finished exactly where I meant to.
That is a genuinely great way to win every single race you enter.
And a phenomenal way to lose millions of dollars on useless AI projects that don't actually solve the business problem.
So what's the summary anchor here?
Success criteria are the rule book. You write the rules before you are allowed to play the game.
Because if you don't know what the target should be, you can't play.
Right. And if you genuinely don't know what the target should be because the domain is too new, then you need to fund a smaller, separate pilot project just to figure that out.
A discovery project.
Exactly. But you cannot start the main build without a definition of success.
Okay, that resonates deeply. I won't get tricked by the agile adaptation excuse again.
Good. Let's tackle concept 2. Concept 2. Go, no go as a recurring decision gate.
Wait, pause. Hold on.
What's wrong?
We already did go, no go in segment 1. You explicitly told me it was phase 1.
I did tell you that. And I also told you it was the #1 student error on the exam.
Okay, I am listening very closely now.
Go, no go is a recurring gate.
Recurring.
It starts in phase 1. You must do it there. But it happens again.
Where else does it happen?
It is a formal gate at the end of phase 3, phase 4, and phase V.
So it is not a one-and-done checklist?
Definitely not. Think of it like clinical trial phases for a brand new drug.
Okay, clinical trials.
You have phase I safety trials. At the end of phase 1, there is a go, no go meeting. If you pass, you get funding to go to phase 2.
Right.
At the end of phase 2, there is another go, no go meeting to look at efficacy. Just because you pass the basic safety check in phase, it doesn't mean you get a blank check to skip the efficacy check later on.
That makes total sense in medicine. You are constantly reevaluating the risk.
AI is exactly the same. Just because your initial idea was good doesn't mean the execution is actually working out.
So let's look at a hard scenario for this one.
Let's bring back Metasort.
Our favorite ER triage bot.
Metasort passed the phase I go, no go perfectly. Let's assume they solved the messy PDF issue. They got access to a beautiful, clean, structured database of historical records.
Smooth sailing.
Business is great. Data looks highly available. IT is ready to rock. So they move forward.
Okay.
They get all the way to phase 3, which is data preparation.
Right.
They start having doctors actually label the data, marking which historical patients truly needed critical care versus those who didn't.
Okay.
And they discover a massive problem. There is extreme inconsistency in the labels. Dr. A labels a mild chest pain as level 1 critical, but Dr. B labels the exact same symptoms as level 3. Wait.
Oh boy. Classic real-world human data problem.
Exactly. The data is hopelessly noisy and contradictory. The lead data scientist comes to the steering committee and says, guys, we cannot train a reliable machine learning model on this. The ground truth is a mess. It's garbage in, garbage out.
They have to stop.
But the project manager, our guy Steve
again.
Steve argues back. He says, hold on. We already passed the go, no go gate in phase 9. We officially got the green light. We have the budget allocated for the entire fiscal year. We can't give it back now. Let's just keep pushing into phase 4 and see if the neural network can magically figure out the patterns anyway.
I mean, I hate to admit it, but Steve kind of has a point about the budget. Once you have enterprise budget, it is incredibly hard to give it back without looking like a failure.
But they did pass phase 1.
They did. But the reality on the ground has fundamentally changed. The data itself implies they can't actually build a safe model.
So,
Yeah.
What is the CPMAI ruling?
So they have to stop, or at least pause and reevaluate.
Yes. This exact situation triggers a phase 3 go-no-go decision. The fact that they passed phase I 3 months ago is completely irrelevant to the current feasibility crisis.
So the right answer on the exam is stop and reevaluate. You don't just plow through phase 3 because you got a stamp of approval back in phase 1.
Exactly. Steve is falling victim to the sunk cost fallacy.
Right. We've spent so much time already, we have to finish.
And the CPMAI framework is designed to break the sunk cost fallacy. It forces you to stop and ask the 3 feasibility questions all over again.
Business, data, execution.
Yes. Is the data feasible?
Yep.
In phase 1, looking from the outside, we thought, yes, we have a database. But in phase 3, looking at the actual labels, we realized, no, the labels are garbage.
The answer changed.
And because the answer changed, the project status must change. It becomes a no-go.
Okay, the summary anchor here is so clear to me now. Go-no-go happens at phase 1, 3, 4, and V. It is not one and done.
Beautifully stated.
Okay, that is a huge conceptual shift for me. I definitely thought of go-no-go as literally just a start button you press once.
Most people do, and that's why they fail the scenario questions. Now, we are ready for concept 3.
Let's do it.
This is the one we touched on at the very beginning of the show, but we are going to formalize it right now. This is the ultimate showdown on the exam.
Trustworthy AI versus go-no-go.
Yes. The can we versus should we dilemma.
I am ready.
Here is the deadliest trap on the entire phase I exam. I am going to walk you right into it, so be on high alert.
Shields are up.
If I do the go-no-go check,
Okay.
and I rigorously verify business feasibility, data feasibility, and execution feasibility,
All 3 are green.
haven't I technically checked if the project is trustworthy?
Okay, see, my brain desperately wants to say yes to that.
Why?
Because surely business feasibility includes the question, is this legal?
Right.
Like doing something blatantly illegal isn't feasible for a business.
Well,
If a bank builds a racially biased algorithm, they're going to get sued by the government. Getting sued is catastrophic for business. Therefore, isn't ethical compliance naturally baked into business feasibility?
that is exactly the logic that fails the exam.
Wow.
And frankly, it's the logic that fails in the real world, too.
Really? Why? It seems so rational.
Because short-term profit motives almost always ignore long-term risk. The go-no-go gate covers purely mechanical feasibility.
Mechanical.
Yes. Can it be done? Will it make us money this quarter? Do we have the raw data files today?
Okay.
Trustworthy AI requirements is a completely separate task group. It specifically covers ethics, legal laws, explainability, and failure modes.
They are completely separate boxes on the checklist.
Totally separate boxes. Let me give you the scenario to prove it. We are back to Metasort.
Okay.
Phase 1. They have completed determined business objective. They have completed success criteria. They have cleared the AI go-no-go.
So they check the boxes.
Yes. Business is green because it will save money. Data is green because we have the records. Execution is green because we have the team.
Sounds like a textbook green light project.
So Steve, our project manager, says, "Great job, everyone. Phase 1 is done. Let's move to phase 2 and start designing."
Classic Steve.
But an external auditor steps in. The auditor flags that the required ethical AI considerations document and the AI failure modes analysis are entirely missing from the Phase I package.
What did they miss specifically?
They haven't analyzed if the historical training data is biased against patients arriving from lower income zip codes.
Oh, that's a massive oversight for a triage bot.
Huge. But Steve says, look, we cleared the formal go-no-go gate. We have the budget approved and the data secured. Phase I is officially closed. We can figure out the zip code bias stuff later in testing.
Okay, let me walk through this logic out loud.
Do it.
The go-no-go is green. Steve isn't lying about that.
Correct.
But the ethics documentation is missing.
Correct.
Steve says Phase I is done because go-no-go is the final gate. But you just told me they're separate task groups.
I did.
So, Steve is wrong. You absolutely cannot close Phase I without completing the trustworthy AI tasks, even if you pass the go-no-go gate with flying colors.
Exactly right.
Wow. That is tricky. because in standard project management, you really do assume the go, no-go is the final boss of the phase. Once you beat it, you move on.
It's not the final boss. They are parallel obligations. You must satisfy both.
Because you can have a project that is perfectly feasible, but totally unethical.
Exactly. You can have a project where we have the data, we have the money, we can easily build the code, but it is completely illegal to deploy.
Give me a non-healthcare example to really cement this.
Okay. Think about robbing a bank.
Robbing a bank.
Yes. If you have a really fast getaway car, a highly skilled crew of safecrackers, and you somehow bought the vault combination from an insider,
Okay.
is robbing that specific bank feasible?
Well, yes, you have the data, the combination, and you have the execution, the crew, and the car. And the business case is all the cash in the vault.
Exactly. The go-no-go gate is perfectly green. We can definitely rob this bank.
Right.
But is it trustworthy?
No.
Yeah.
It is highly illegal and wildly unethical.
Exactly. Robbing a bank might be incredibly execution feasible. It is absolutely not trustworthy.
That is hilarious.
The go-no-go would say, yes, we can do it. The trustworthy AI chick would scream, no, we definitely shouldn't do it.
Okay, that is going to stick in my brain forever. A project can be a perfectly feasible bank robbery.
Exactly. So what is the summary anchor here?
go asks, can we build it? Trustworthy AI asks, should we build it, and how do we keep it safe? Never mix them up. You need two separate green lights to leave phase I, not just one.
Can we versus should we? You've got it.
I really do. This has been incredibly helpful.
Well, don't celebrate just yet. You've survived the deep explanations.
Oh, no.
Now we are going to test your actual reflexes.
Reflexes.
Welcome to segment 3, rapid fire.
Oh, boy. Okay.
I am going to throw 4 fast scenarios at you. These are straight out of the exam style.
Okay.
I want one-sentence answers. I am correcting your instincts here. Don't overthink it. Don't hem and haw. Just react with the rules.
Ready. Hit me.
Scenario 1. A human resources firm is building an AI resume screener. They want to write the required AI explainability documentation during Phase 6 deployment so that the document perfectly matches the final written code instead of guessing in Phase 1.
Wrong. It must be phase 1. It's the fire code blueprint.
Correct. Trustworthy AI is a strict Phase I obligation. Scenario 2.
Go.
A logistics project passes the Phase I go-no-go perfectly. 9 months later, in Phase 4, the model fails all of its baseline performance tests. Do we need a formal decision to stop the project, or is it automatic?
We need a formal decision. The go-no-go gate recurs in phase 4.
Correct. Scenario 3.
Okay.
The project sponsor wants to change the acceptable KPI performance value from 15% to 12% because the model result was lower than expected, and they just want to get the project approved before the quarter ends.
Absolutely not. That violates pre-commitment.
Correct. It requires formal change control, not just a quiet edit. Scenario 4, last one.
Free no.
The project manager claims that data feasibility is naturally covered under trustworthy AI requirements because using bad data is fundamentally unethical.
Wrong. Data feasibility is strictly part of the AI go-no-go gate.
Correct. Do not mix the task groups. You nailed all 4.
Phew. I actually felt surprisingly confident on those.
You should. You have successfully separated the concepts in your mind. The mental model is fixed.
Okay, let me just quickly summarize what changed for me today, because this was a huge shift.
Go for it.
The first big shift. I honestly thought go-no-go was just a one-time start button at the kickoff meeting. Now, I know for a fact it's a recurring check throughout the life cycle.
Yes.
That clinical trial metaphor, having to check efficacy again in phase 3, that really helped lock it in.
It is a life cycle check, not a front door gatekeeper.
Exactly. And secondly, I will never, ever confuse feasibility with trustworthy AI again.
Can we versus should we?
Right. Can we build it versus should we build it? They are entirely separate boxes on the phase I checklist. The bank robbery analogy, a project being completely feasible but totally untrustworthy, is going to stick with me into the exam room.
I am very glad to hear it. You are ready for this section, but I want to leave you with one final anchor.
Okay, what is it?
The most exam-critical takeaway from this entire session, if you forget everything else, remember this overarching theme.
Lay it on me.
Phase I is entirely about governance.
Government.
It is not about brainstorming cool AI ideas. It is not about experimenting with Python libraries. It is about establishing strict governance.
Because you have to set the rules.
Yes. If you don't write down the acceptable performance values and the ethical requirements before you start building,
Then what are you doing?
you aren't doing CTM AI, you are just hacking.
Wow. That is a powerful distinction, hacking versus engineering.
Exactly. CPMAI is engineering a solution safely. Hacking is just playing around and hoping it works out.
Well, I feel a whole lot better about staring at that study guide tonight.
Good. You've got this. Just remember the golden rule for your practice exams this week.
Pick your answer before the reveal. Every single time.
Every single time. Good luck with the studying.
Thanks for the deep dive. I feel ready.